these are the solutions for the first 6 problems for the study guide for the Chapter 2 test. So again, these are very similar problems to what you're going to end up experiencing. So if you can do these, you'll do just fine on the test. So first problem, we see it asks us to draw a graph to represent the situation. So what I would do is underline the important parts that you'll end up needing for the graph, so to make sure that you have all the parts in there. And also take a look at what the graph is saying. So for instance, the y-axis is telling us it's the distance from home. So this is distance we've got, and time is the x-axis. So it says Mike drives to work in the morning. So he's driving to work, so that means he doesn't automatically get there. So it's not starting up here. This is the distance from home. So this is home right here. And so we're going to have him drive to work. So he's going out to work, and then he remains at work. So again, drives to work was the first part. I've got that part of the line in there. It's an increasing line. And so when I see the word and, that means we're changing now. And now we're changing to he stays there for 4 hours. So he stays there for 4 hours, meaning he's not going any further from home. So it's going to be a horizontal line. And so it says 4 hours before returning home. So then he returns back home. And we'll go down that way. And then we end up seeing that he's going to stay at home for 2 hours. So he returned back home. So we drew that part of the line. The line going horizontally out in this direction means that he stayed at home for 2 hours because he's already home. So that's why we're down here at the bottom. And then he goes back to work and stays there for 2 hours. So goes back to work. So we're going the same distance back. And he stays there for 2 hours before he returns home again. So a little bit shorter distance that time for staying home, and then he returns home again. So that's what we're looking for matching what we've got there. So again, he stayed home for 2 hours and then returns home once more. So the next graph's a little different because instead of distance, we've got speed for the y-axis. Time is the x. So let's see what it says. So draw a graph to represent the situation. Ed drives his car at a constant rate of speed for 30 minutes. Okay, so he's driving at a constant rate. Let's say he ends up starting at no speed. So he drives to a constant speed. So I'm going to assume that he started at no speed, and then they're saying he drives at a constant speed. So that's why I'm going straight across, because that speed's not changing. He does this for 30 minutes. Then he slows down to a stop. So again, I'm assuming again that he started at 0 miles an hour, and he drove to that constant speed for 30 minutes. Then he slows down to a stop. So he slows down and he stops. That means we're at the bottom of the graph on the x-axis. He stays there for 10 minutes while he takes his lunch break. So we'll go over for a little bit, showing that I've gone over for 10 minutes. And then he starts riding again, but this time at a faster pace than before. So we have to go above the line that we had before and then continue it out. And they don't mention anything else, so we'll just stop the graph there. The next question asks us to determine whether the relation is a function. So to determine that, I'm looking at the inputs. So the inputs are the x values, and then I'm going to compare those to the outputs. But first, I have to really look at the inputs to see if I see any numbers repeating. So if I see a number repeat, then I would check to see if it has a different output. And I don't see any numbers repeat here. So that means this is a function. So we say the relation is a function. And I would say because each input has only one output. So every single input only has one output, and that's why it is a function. So the next one says explain whether the relation is a function, but they've got the relation in a different setting. Instead of a table, we've got a graph. We've got ordered pairs. So I look at the domain, or the inputs. The domains are the inputs. So 3, 2, 9, 6, and 3. See how the 3 repeats? We've got a 3, and here I've got a 3. And look at the output. So notice how here I have 3 and 8. Here I have 3 and 4. So this is not a function. Not a function. And the reason it's not a function, because the domain 3 has 2, and domain means the same thing as input. So we're using input in this class, so I'll go ahead and use that. So the input 3 has 2 outputs. And that's the explanation we need for that one. So let's take a look at the next one, and it talks about we're supposed to determine whether the ordered pair, they give us that here, is a solution of this equation. So what we need to remember is the first number is x, the second number is y. And we're going to take our ordered pair and put it in place of the x and y in the equation. So what we've got is negative 6, that's the y value, equals, and then we have 6 minus 3 times x. Well, x is 4. So then we go ahead and once we've substituted, we do the work. So negative 6 equals 6 minus 12. So I have to multiply first, and then I see negative 6 equals negative 6. I subtract 12 from 6, and that's what I get. So when they are the same number like they are here, we would say yes, the ordered pair, and then I'll go ahead and tell what that ordered pair is. 4 comma negative 6 is a solution of the equation, and then I can state what that equation is. Y equals 6 minus 3x. So the next one says to write an equation to represent the data. So what we're trying to do is see how they're going from the x term to the y term. And if you don't see it right away, then remember that we can always check for a common difference or a common ratio. So let's check for a common difference. So when I'm talking about a common difference, I'm looking at the y and the x value. I'm seeing if y minus x gives me the same number. So let's go ahead and check. So when I do the y, I go 4, and then I do the x, corresponding x value, it's negative 3. And remember, add the opposite there, and that would give me a positive 7. So again, the rule is minus negative makes plus positive. So we do that with the other ones. I have 5 minus negative 2. I have the same thing. I add the opposite, and that gives me 7. So you can see it's working. 6 minus negative 1. I add the opposite again, and that gives me positive 7. And obviously 0 minus 7 is going to, oops, 0, did that one wrong. So always remember, I made a mistake there. You've got to put the y first, otherwise you'll end up making an error like I did there. So I've got to do 7 minus 0. So if you catch yourself and you see they're not the same number, then you know something's wrong. And obviously the last one, 8 minus 1, is also going to be 7. So I know 7 is a common difference. So the way we're going to do that is we take the common difference and we combine it with the x. And so if the common difference is a positive, it's going to end up being a positive number. So you see it's x plus 7. If I take the x value, let's take this one, it's easy for now, and I plug it in for the x value here and the y value, and I add 7, you see how you get the same number. So it does work out. So y equals x plus 7 would be the solution. Well, that's the first 6 problems. Check out the next part for another set of problems.